Hi, welcome back to my channel. Can you solve this problem and find the shaded area? We are told that AB is equal to BC is equal to 4 centimeters, which is the radii of all three of these circles because they overlap and the circumferences go through the centers of the other circles. Now this problem was described as being an impossible question on a GCSE exam, and thousands of kids were left baffled by this question. They claim can't be solved. Can you find the answer? And it leaves students in despair. Can you work it out? Now, I'm going to show you my solution in 3, 2, 1. Pause the video now if you want to do it yourself. Otherwise, let's get into it. Okay, so whenever you've got circles, what you want to do is draw on any radii that you can so that it will help. So if I start with a left-hand circle here and draw the radii on, so going from the centre to the circumference of that circle, and then if I do the same with the middle circle, so draw the radii on there from the centre, and then the same with the right-hand circle going from the centre to the circumference, putting my radii on. Now, we were told that AB is equal to BC is equal to 4 centimeters, so we can put all of those on. And now what we can see is that we've got 4 equilateral triangles, which therefore means all the angles will be 60 degrees. Okay, so at this point, it's starting to make a bit more sense, hopefully, how we can find this shaded area. Now, one thing we can do, if you think about it, you probably are thinking about it because you're watching this video, you can do this, the area of the middle circle, take away 8 segments, so I'm going to call those 1, these segments, and then also take away 4 triangles, and I'm going to call those 2, just to make it a little bit easier in terms of working out and knowing which one's which. But because they're identical, because of this symmetry, we've got the same segment 8 times and the same triangle 4 times. Okay, so 8 lots of 1 and 4 lots of 2, and we're going to take that away from the area of the circle. Now actually we only need to consider one of these sectors to work out the area of the triangle and the area of the segment. Let's make it a little bit bigger. So first thing we need to do is work out the area of the sector, and that's the piece of pie, the piece of cake. It's the whole thing. It's not 1, it's 1 and 2. So the area of the sector is 60 because that's the angle out of a total of 360 degrees in a circle times pi r squared. That gives us an answer of 8 over 3 pi. We can then work out the area of the triangle by doing a half AB sine C, where A and B are 2 sides of your triangle and C is the angle in between them. That gives us an answer of 4 root 3. And we can replace these, the area of the sector, with uncircled numbers. So 1 add 2 is the area of the sector, and the area of the triangle, well, that's 2. And so it's a little bit easier to see now with the labelling that actually if we subtract 4 root 3 from 8 over 3 pi, we're going to get the area of 1, which is the area of the segment. So take those away like that. Now, we only actually need 1 and 2, so let's get rid of 1 plus 2, which is the area of the sector. Now, we then need 8 lots of equation 1. So we're going to work out the area of the circle first, which is 16 pi. We're going to plug that in. Then we're going to do 8 lots of 1, which is 64 over 3 pi times the 8 over 3 by 8, so 8 times 8, and then times the 4 root 3 by 8, which is 32 root 3. We're going to do a similar thing with that second equation. We're going to times that by 4, so we can substitute this into that top equation then for the shaded area. So the number 2 equation times by 4 is 16 root 3. Now before we substitute this in, let's add it together because then it's going to be easier to subtract. So we're going to add those 2 equations together, and we're going to get 64 over 3 pi minus 32 root 3, which was 8 lots of 1, plus 4 lots of 2, which is 16 root 3. We can simplify that to 64 over 3 pi minus 16 root 3, and now we can substitute that into that top equation, and we get the shaded area is 16 pi minus all of 64 over 3 pi minus 64, that's minus 16, sorry, root 3. And we're going to distribute that negative outside of the bracket. So we're going to make sure that we have minus or subtract 64 over 3 pi. And then we're going to have a negative times a negative. So it will be positive or plus 16 root 3. We can then simplify that by doing 16 take away 64 over 3 for the 2 pi terms. And that will give us a final answer for the exact value of 16 root 3 minus 16 over 3 pi centimetres squared. It's a pretty nice answer to this problem. Were you able to solve this? If you were, let me know down in the comments below. Could you solve this impossible problem? If you did it a different way as well, please let me know and share with other people down in the comments below. And that just leaves me to say thank you very much for watching. If you haven't already, please like the video and consider subscribing to the channel. I very much appreciate all the people that have subscribed. Yeah, it means the world to me. So yeah, if you're not already subscribed, please do consider that. Thank you very much. Thank you very much for watching. I will see you next Monday at 5 PM for another problem solving video. Until then, bye bye.